Hi Ash, let's check this one out. So here's what I'm going to do. You were off to a great start there. The thing that I suspect where you went wrong is probably where myself and a lot of people go wrong with these. It's like keeping everything straight, right? We have to do so much. We have to find all these angles and all these sides. What goes what? How do you figure that out? So what I'm going to do is I'm going to draw a diagram and I'll try my best as I work the problem to update that diagram. So I always think of it like this. We have some line coming in, we have another side coming in, and then we have another side here. Where this is going to be angle A, so this would be side A. In this case, we know angle A is 50 degrees, and we know side A is 11. I would then call this side B over here. This is B, which is going to be 13. And then we're going to have C up here, up top. So this is angle C, side C, angle B, and I don't know where A is yet. We're going to figure that out. So that's the first thing. Always draw your diagrams like this, where A is the first thing as we move left to right, but then C has to come next. C is at the top because the longest side by convention of a triangle is going to be C, right? And we use C for the hypotenuse, so we just try to follow along with that. Next thing we're going to do is we're going to compute the height. So we got to figure out what the situation is here. Is this one triangle? What's going on here? And the height is found by multiplying b times the sine of a. And where that comes from, if we imagine we just draw a nice straight line straight down here and we make a right triangle, this is just a rearrangement of the sine, right? Sine of 50 is opposite over hypotenuse, and if we rearrange that, we're going to have the sine of 50 times b times 13. So that's all that is. We're just using our good old like so, right? Sine is opposite over hypotenuse. There we go. So when we compute that, that's going to be 13 times the sine of 50, 50 degrees, so make sure your calculator is in degree mode. And I worked that out already. It comes out to about 9.96. So what we have here, I always think of this as like ba, right? With right facing inequalities. So if B is greater than A and B and A are greater than H, we're going to have two triangles, right? Two triangles. So I always think like, bah, now you got to work it out twice, right? It's double the work basically. But look, B is bigger than A and A is bigger than H. So that's the play here. That's the situation. We know we have two triangles. So I'm going to update my little sketch now. Let me erase all this. And we know what A is. So because we have A, because we have this two triangle situation, A could go this way or it could go down in here. Right? Now this is not the scale, but this is 11 and this is still 11. A is always the same. So I could label a few things now. I know that I'm going to call this triangle on the left triangle 1. So this is going to be angle C1. Oh, I should do that in black. You'll follow me along, I hope. This is going to be angle C1, and down here is going to be angle B1. Right in here is going to be angle B2. Down here is going to be up here will be C2. And that's pretty much what we got, right? This is going to be angle A again over here, so there's no real need to, you know what I mean, mess that around. We're just going to work from this. That's all we really need to know. So C at the top, B's down at the bottom. This is triangle 1 on the left and triangle 2 on the right. So what I'm going to do now, I have a complete ratio for A. I know what angle A is and I know what side A is. So let's work right in here. I know side B. Let's find angle B right there. So I'm going to use the law of sines first, and we'll go after that right there. So the sine. Oh, get out of there. Get out of there. So the sine of B1 over the side B1, which is 13, is going to equal the sine of A, which is the sine 50 over 11, right? So we're going to go after that. I got my notes here just so it like save you from watching me calculator stuff. So remember we cross multiply here. The sine of B1 comes out to a crazy decimal, 0.9053. So remember you got to do the arc sine, right? Like the opposite. On your calculator, it's probably sine -1. This is not the cosecant. That's a different thing. This is the arc sine, which basically cancels this off and converts this decimal to a degree measurement of that angle. Remember, with our angles as well, we always round to the nearest whole degree as well. So B1 is going to be about 65 degrees. You might have to do a little bit of rounding on that, but you should get it there. So that's B1. And now that I know A, B1, so right here I can rewrite that in. B1 we know is 65. now I know A, B1, we can find C1, right? Because all three angles have to add up to 180. Sorry, clicking around here. So again, I'm just working in this triangle. I'm going after all my angles first. So 180 minus, and again, if you calculated that out, 180 minus 65 plus 50, that's going to be 100. No, it's going to be 65 degrees. So C1 is going to be 65 degrees right there. So that's cool. Now we're going to find B2, and if you look right here, we're going to pretend this is a perfectly straight 180 degree angle, right? A perfectly straight line. So if this is 65 right here, angle B1, B2 can be found by taking 65, subtracting it from 180, and that's what we'll have left. So if we do that, B2 is going to come out to be 115 degrees. So again, this is a part that a lot of people forget, but the diagram helps you see that, right? Because they ask like, well, why 180? Why is that? That's why, because they share a common straight angle of 180 degrees. So 65 minus 180 gives us 115. Now I know A, B2, we can find C2 again by just using the fact that this triangle, triangle 2, has to add up to 180. C2 is going to come out to be 15 degrees. So that's kind of the play, Ash. We always go after our angles first. Do as little algebra as you can. Go after all your angles just by using the fact that they share common things, right? 180 is a common number that pops up a lot. So now we're going to go after side C1, which is down here, and side C2, which is down here. We're just going to use our law of sines for that. I'll get a different color. Okay, so C1 I'll start with. C1 over the sine of C1, which is sine of 65 degrees. That equals, I'll just compare it to A. You could compare it to B at this point too, but you know, we're given A, so we might as well keep it classy. If you compare it to B and you get B wrong, we're going to get this wrong automatically, so I'll go with good numbers. Cross multiply, work your magic. C1 comes out to be 13. Remember, we always round to the nearest tenth, I believe, right? 13 comes out perfectly, and you got that. And now C2, same deal. It's going to be over the sine of C2, which is the sine of 15. Again, I'll compare that to my complete ratio with A, 11 over sine 50, right? Cross multiply, C2 comes out to be 3.7. Okay, so you're off to a great start. You actually solved the first triangle, but I think just doing the diagram will help you a lot as well. P.S. I got your text. It's awesome that you love stats. I hope you have a lot of fun. Don't forget to do your course feedback and your final reflection as well. I hope this helps, Ash. Let me know if it doesn't.